go ahead and look at some examples here of what this mole ratio is. Mole ratio, it's looking at the number of moles of an element in comparison to 1 mole of the compound. So here an example, let's look at H2O. Let's say that in an example I have 1 mole of H2O. We can write mole ratios for H2O. So the mole ratios. Again, the mole ratio in 1 mole of H2O. Well, for example, how many moles of oxygen are in the H2O compound? Well, there is no subscript here, so we imply that it is 1. So there is 1 mole of oxygen per 1 mole of H2O. In comparison, we also have 2 moles of hydrogen per 1 mole of H2O. And that's because of this subscript here for hydrogen. This subscript right there on hydrogen is going to come up here to do 2 moles of hydrogen. Let's look at this example. Be and then NO3 with this subscript on the outside. So if I were to write a mole ratio for Be and NO3, I would say that there is 1 mole of Be, beryllium, per 1 mole of Be, NO3 with a subscript 2. Reason being is because if you look at the compound, the subscript there is 1, so it's 1 mole of beryllium per the entire compound. The other possible mole ratios that exist, and I'm just going to go in order. So I did Be, I'm going to do nitrogen next. There are subscript 2 on the outside. I have to distribute it. 2 moles of nitrogen per 1 mole of Be, NO3 2. Continue going. I did nitrogen. Now let's look at oxygen. 2 times 3 is 6. So 6 moles of oxygen per 1 mole of the Be, NO3 2. So those are the mole ratios that exist for what we use in the double roadmap mole conversions. Let's dive in and look at an example problem here. Basically, we have ibuprofen. There's its chemical formula. And you are asked this question. How many moles of ibuprofen are there in a bottle of ibuprofen containing 33 grams? Well, first and foremost, we need the molar mass of ibuprofen. So I need to do 13 C's plus 18 H's plus 2 O's. I add that all together, I'm going to get 206.34. So that's a good starting spot. Now, if we move on to looking at how many moles here and trying to answer our question, let's go ahead and start any problem, any conversion. We always start. You start with what you're given over 1. So I'm going to start my mole conversion as 33 grams of ibuprofen. I'm actually going to write out C13, H18, O2 over 1. Set up your train tracks or your railroad tracks, and I have grams up here. I'm going to go grams down here, and it's going to be the exact same thing of C13, H18, O2. And I'm trying to get to moles, the GMA. I'm trying to get to moles of C13, H18, O2, because I'm going from grams to moles. In 1 mole, because it's always 1 mole as a conversion factor, how many grams of this compound exist? That's its molar mass. I'm going to look on the periodic table. I already have it together, so it's 206.34. I'm asking for how many moles. My grams cancel, and I'm left with the word mole. So I know that I'm at my last step. So my last step is to divide the 2 and and I'm going to get an answer of 0.1599. I need to check my sig figs here. I'm giving 2 sig figs in the problem, so I have to round this off to 2 sig figs, so 0.016 moles of ibuprofen. And you could do the C13 H18 O2 as my final answer. So let's continue here and look at another example problem. I'm dealing with how many molecules now of ibuprofen. And remember that ibuprofen is C13 H18 O2. Now I'm looking at how many molecules of ibuprofen are in the bottle. Well, if I'm already in moles from up here in this answer, I can just use that as an answer down here. Now, realistically, you could just continue off of this conversion to make the mole conversion work, but I'm going to go ahead and just use the 0.16 moles of my compound C13 H18 O2 and convert that. So let's go ahead and set up my conversions. I have mole here, mole better go down here, and I'm going up to molecules. So in 1 mole, how many molecules are there? I know that in 1 mole there are my 6.02 times 10 to the 23rd molecules in 1 mole. Moles cancel, and I can multiply across. Multiplying across gives me 9.6 times 10 to the 23rd. Molecules of my ibuprofen. C13 H18 O2 as an answer. One last problem here and we are finished. Last problem. What is the total mass in grams of carbon in my bottle? Knowing that there's the formula for ibuprofen and the molar mass of that compound is 206. So now I have somewhere else I'm going. I'm going to just C, just carbon out of the compound, which makes it a little bit more challenging. So here, what I'm going to do, I'm going to start with, I can do 2 choices here, what to start with. What is the total mass of carbon in the bottle? Initially, if you look at the problem, initially I was given 33 grams of ibuprofen. So that's what I want to use, and go ahead and I'm going to stick with 33 grams of ibuprofen are in the bottle. So I know that I have 33 grams of this. So I'm going to start with what I'm given, 33 grams of my C13 H18 O2 over 1, and I'm going to get it into moles. I always want to go to moles. So I'm going from grams to mole. In 1 mole, how many grams are there of my compound of C13 H18 O2? 206.34, because I added this up off of the periodic table. I added the values up. Grams cancel. I'm in mole here of C13 H18 O2. Now this is where your mole conversion or mole ratio comes into play, and where this is really important for you to look at if you need to. So I go back to here. This is my mole ratio. I was just in grams of a compound, 33 grams of ibuprofen. I divided by the mass of the compound to get it into moles. I need to now go down to the element in the compound and then back over to get to the mass of just the element. So bear with me here. I'm going to use my mole ratio here, which is the subscript of the element over 1 mole of the compound, to go from a compound, which is ibuprofen C13H18O2, into a single element of that compound, just carbon. So let's apply that mole ratio here to our problem. Right now, I'm going to apply this mole ratio as a conversion factor. If I have a mole of C13, H18O2 up there, I know that I want a mole of C13, H18O2 down here. And that's 1 mole of my compound. And then how many moles of carbon are in that compound? This is the mole ratio. I have 13 carbons in one compound, the subscript 13. That's my mole ratio. So I use that to cancel out my compound of ibuprofen, and now I'm in moles of carbon. Now it's just a mole to gram conversion of an element, which you've done many, many times. I have moles of carbon up here. I'm going to put mole of carbon on the bottom. In 1 mole of carbon, how many grams of carbon are there? And that's where you need to look on the periodic table, and you can find carbon's mass is 12.01, and my moles will cancel. I'm going to simply divide, then multiply to get my final answer. Typing it in your calculator, which you should see here as my final answer there of 24.96, rounded with sig figs, I'm going to end up with 25 grams of carbon in my bottle.